Hi, my name is Aaron F. Ross, and welcome to this free video tutorial on Maya Forward Kinematics. What is forward kinematics? Kinematics is the measurement of movement, specifically, in this case, the rotation of joints. The term forward kinematics is used to differentiate from a computer graphics technique called inverse kinematics, which is a goal-driven technique. Forward kinematics is essentially a synonym for a standard animation hierarchy, in which you've got parent-child links. One object is the child of another. In forward kinematics, children inherit the transforms of their parents. If a parent rotates, then the child will rotate to move with it. In inverse kinematics, it's kind of a backward relationship where the parent actually inherits rotations from the position of the child. We're going to learn forward kinematics, or FK, in this lesson. I've got some scene files that we can open up. First, let's set our Maya project as always. File, project window. I'll create it in the standard users documents Maya projects. Click new and simply call it FK project. Click accept. I'm going to minimize Maya, go out to my desktop, and I've downloaded these files from digitalartsguild.com. Select those two and right click and copy them. Go into my new project that I've just created. My documents, Maya, projects, FK project, scenes. Right click and paste that in. Go back to Maya and open the scene. File, open scene. Robot no rig. And what we see here is a collection of mesh objects that are not linked to each other. They are on a display layer, as you will see here. I can toggle their visibility. There's no other organization to the scene. Let's open the outliner and investigate the hierarchy there. Window outliner. And you'll see that there is no hierarchy. Everything is flat. It's all at the same root level. I can create a group here just for convenience sake of all the robot mesh objects. Just drag my mouse across all these that say robot mesh. Go to the menus and choose Edit Group. And let's rename the group as well. Double click it. I'll call it Robot Mesh Group. Good, now we put all of those mesh objects into their own group, just for convenience sake in the outliner, so they're not cluttering that up. In fact, we could do the same with these lights if we wished. Edit Group, and rename it Lights Group. As I examine this model, it appears to me that I could probably optimize my rig by opening these claws up a little bit more. That means that I need to rotate them and reset their rotations before I connect them to any joints. In order to rotate them correctly, I'll need to move their pivot points. If I select the object and go to the Rotate tool and try to spin it, it doesn't spin around the correct location. I need to move its pivot. I'll hit Z to undo that. Moving pivots is pretty easy. On Windows, just press the Insert key and you'll be in pivot point mode. And you can just move that pivot point wherever you want. And then to exit, just press Insert again. On the Mac, you don't have an insert key, but you can hold down D. And as long as you're holding that D key down, you can move the pivot point. When you release the D key, you go back to whatever transform mode you were in. I can select more than one object at a time and move their pivots. In order to do this, I probably want to snap to something. Go up to the snaps on the status line here. I'll enable Snap to Grid. Tap the spacebar and do this in the side view here. Press the F key, getting closer. Zoom that viewport. And once again, hold down D with snaps turned on. And I can move both of those pivot points at once. And then release the mouse. And you'll see, if I select either one of them, the rotate gizmo is located here. Very good. I'm going to select them both again. And just fine-tune that pivot location without the grid. Snapping off, use the Move tool, and hold down D. Just pull that up a little bit until it's centered. Then test the rotations. You can just grab the Rotate tool and rotate them both at once, in fact. And you'll see they're rotating. We can try them individually. At this point, they're fine. Now we want to open them up a bit. We're just going to guess how much that's going to be. Check that in the side view, just so that it's not intersecting with any of the nearby geometry. It looks like it is actually buried inside some geometry here. So, in fact, I'm going to undo those rotations And grab those and move those up a little bit. So I'm using the E key to go to the rotate tool. And as I rotate that over, it looks like about 90 degrees. We do the same here. It's going to be negative 90. At this point, we can freeze the transforms on all of the objects. And that'll set these rotation values to be the new default 0 values. Let's go into our robot mesh group and select all the objects. And then in the menus, choose Modify Freeze Transformations Options. Make sure that Translate, Rotate, and Scale are all enabled. Those are now the default rotations for the finger objects there. We're ready to build out a skeleton, which is a system of joints. To facilitate that, we should have Snap to Grid turned on. Currently, the grid is pretty tight. The grid squares are small on my scene currently. I'm going to change the grid settings to make it easier to build the skeleton. Display grid options, length and width of 300, grid lines every 100, and subdivisions of 10. Click Apply and Close. And now I've got a grid line every 10 centimeters. I've got Snap to Grids turned on, and I want to build the skeleton in the side view. Go over to the side view and tap the space bar. We want to be in the Animation menu set. And go to Skeleton, Joint Tool, Options. And click Reset just to restore it to default options. We want to change these radius values because our scene is built at 1:1 scale, and that would make the joints very small and hard to see. I'll set the short bone radius to 2, and the long bone radius I'll set to 3, and then I can close the tool settings window. Start from the bottom with Snap to Grid turned on. And between the base and the swivel object, let's click to create our first joint. And then between the swivel and the shoulder, just making sure that you're snapping to the grid intersections. It's okay that we're not vertically aligned because we're going to go back and fix that later. When we get to the top, we need to think this through a little bit. I need the ability to swivel the wrist around, and I need to independently rotate each of these fingers up and down. To do that, I'm going to have multiple joints in the same location. That's just the way that joints work in Maya. So what we need to do is to create 3 joints basically right on top of each other in the center here. Since we don't have a grid intersection handy, we can just go ahead and click here or up here, whichever, doesn't matter. But click once, and then click again in the same place. And then finally, we need to have an end effector or an end joint. Click up here and make one extra one, and press Enter. We can dolly back and kind of take a look at what we've done. We've created a chain of linked joints. Each one lower on the screen here is the parent of the one above it. If I select one of these individual joints and rotate it, you'll see all of its children rotate as well. Hit Z to undo that. Up here at the top, we have 2 that are right on top of each other, and Maya's actually made them slightly different size so we can see that. Tap the space bar, go to the perspective view, and get in closer. And we can select these individually. Joint 6, or use the select tool and select the other one, joint 5. Let's investigate that in the outliner, window outliner. Open up the hierarchy, hold down the shift key and click on the plus sign, and that will open up all of the hierarchy. And we can see joint 5 is the parent of joint 6, which is the parent of joint 7, which is our little end effector here. Okay, we're going to move all the joints around now. To do this, it's very important that you do not rotate the joints. You're going to only position them, and you want their rotations all to stay at values of 0. Grab the Move tool or Position tool. Go into the side view, and we can turn snapping off and position these vertically only, starting from the bottom. This one, it doesn't really matter where it is vertically, because it's only going to rotate around the y-axis here, y of the world. This one, however, we do want to move down a bit. What we're doing is we're moving the pivot point of the joint just by moving the object. And then this stretchy bone that connects the joints is purely a visual indicator. The real transform center is at the center of this cross. Again, I'm only moving these up. I'm not moving them side to side at all. When we get up to the top here, we just want to select the parent joint, which is joint 5. You can check that in the outliner. So joint 5 is currently the smaller of the two. With the parent here, joint 5 selected, I can move it down to center it. And then the end effector, move over to wherever is convenient as a visual indicator of where the end of that object is. We can change the bone radius and display properties to make it easier to see what we're doing when animating. Let's go to the panel toolbar. And up here you will see X-ray joints on the very far right of the panel toolbar. Now the joints are always drawn on top of whatever mesh objects. Very good. So I can select joint 5 and you'll see radius over here in the channel box, and I can increase that, set it to 3. Joint 6 I can change to 2 maybe. And now it's a little easier to see that this is the parent. That's going to be the wrist. That's going to determine the rotation around in this direction. And then joint 6 here is going to be the finger. That'll determine the rotation up and down this way. And again, this guy at the end is there just for visual reference. If we delete that, then we will delete this bone and we won't be able to see how we're rotating things. If we were to set up an inverse kinematics or IK rig, we would also need that end effector or that joint at the end of the chain. All right, so we've got half of the hand finished here. We need to just duplicate that over to the other side. Maya makes it very easy for us to reproduce the joint across an axis, and that's mirror joints. I'm going to select joint 6, which is once again going to be the rotation for the finger. Reset that. With joint 6 selected, go into the skeleton menu and choose mirror joint. And if you wish, you can go to the options to see what's there. We just want to make sure that we are mirroring in the correct axis. And the default is XY, which is in fact what we want this time. Click mirror, and now I've got joint 8 and joint 9. And notice that joint 8 is the child of joint 5. Not only have the joints been duplicated, but they've also been correctly linked in the hierarchy. And in fact, their rotations are also conveniently set up now to be opposite one another. If I select joint 6 and then control select joint 8 and rotate, you'll see that they rotate opposite one another, which makes it very easy for us to animate. All right, so I'll undo that. We can assume a preferred angle for the joints so that if we ever get them out of whack, it'll be very easy to put them back. Just select the first one and then go up into the skeleton menu once again and choose Set Preferred Angle. Once again, that'll be a kind of bind pose or a setup pose that we can always recall if we want to, just by going back up into that skeleton menu and choosing Assume Preferred Angle. We'll snap back to these rotations.